Our objective in this lesson is to multiply radicals. Prerequisite knowledge required are simplifying radicals and adding and subtracting radicals. In multiplying radicals, we follow 3 steps. Step 1, we multiply the terms outside the radical. Step 2, multiply the terms inside the radical. And step 3, simplify. Let's have an example. First one, square root of 3 times square root of 27. The coefficient here is 1 and here is also 1. Since 1 times 1 is 1, we may not write it anymore. So step 2, multiply the terms inside the radical. 3 times 27 is equal to 81. So this is equal to square root of 81. Step 3, simplify. Square root of 81 is equal to 9. Next example, 15 times 1 is equal to 15. 20 times 5 is equal to 100. So square root of 100. And square root of 100 is 10. So 15 times 10. And 15 times 10 is equal to 150. Next one, 1 times 5 is equal to 5. 18 times 2 is equal to 36. So square root of 36. Square root of 36 is equal to 6. So this will be 5 times 6. And 5 times 6 is equal to 30. Another one, 3 times 2 is equal to 6. 16 times 4 is equal to 64. Cube root of 64. Cube root of 64 is equal to 4. So this will be equal to 6 times 4. And 6 times 4 is equal to 24. This time, we are going to use distributive property in multiplying. Let's have an example. Square root of 2 times the quantity 3 plus square root of 5. So let us distribute square root of 2. Square root of 2 times 3 is 3 square root of 2. Then square root of 2 times square root of 5 is square root of 10. Positive times positive is positive square root of 10. Since there is nothing we can factor out from square root of 2 and square root of 10, this will be our final answer. Next one, let us distribute square root of 3. So square root of 3 times square root of 3 is square root of 9. Then square root of 3 times positive square root of 27 is positive square root of 81. Square root of 9 is 3. Square root of 81 is 9. 3 plus 9 is equal to 12. Next one, let us distribute 4x. So we have 4x times 2 is square root of 2. And then 4x is square root of 8. 4 times 2 is equal to 8. So this will be 8x is square root of 2. Factors of 8, 4 and 2. So this will be plus 4x is square root of 4 times 2. Let us copy 8x is square root of 2. Square root of 4 is 2. Let us factor it out. Let's copy again 8x is square root of 2. 4 times 2 is equal to 8 times x is 8x. So this will be 8x is square root of 2. We have same indices and same radicands, so let us add 8x plus 8x, and that is 16x. 16x is square root of 2. This time, we are going to multiply through a square of a binomial. Let us recall the steps here. First step, we square the first term, and 5 squared is equal to 25. Next, we copy the sign of the middle term. Next, we bring down 2 and multiply it with our first and second term. So this will be 2 times 5 times square root of 6. And then we square the second term. Square root of 6 is squared. The third term is always positive. Let's copy 25. 2 times 5 is 10, so plus 10 is square root of 6. Square root of 6 is squared is simply 6. 25 plus 6 is 31, and then copy plus 10 is square root of 6. Next one, once again, let us square the first term. So this is square root of 7 is squared. And then we copy the sign of the middle term. We bring down 2. we multiply it with the first and the second term. So 2 times square root of 7 times the square root of 5. And then we square the second term. Square root of 5 is squared. Remember, the third term is always positive. Negative squared is still positive. Square root of 7 squared is 7. And then square root of 7 times square root of 5 is square root of 35. So this will be minus 2 is square root of 35. Square root of 5 squared is simply 5. 7 plus 5 is equal to 12. And then copy minus 2 is square root of 35. This time, we are going to use the SMILE or FOIL method in multiplying. I'll use first the SMILE method. So 8 times 2 is equal to 16. And then square root of 5 times square root of 3. Negative times positive is negative. So negative is square root of 15. Then negative square root of 5 times 2 is negative 2 is square root of 5. And last, positive 8 times positive square root of 3 is positive 8 is square root of 3. Since there is nothing I can factor out from square root of 15, square root of 5, and square root of 3, this will be our final answer. We just have to rearrange them. So let's start with 16, followed by plus 8 is square root of 3, and then minus 2 is square root of 5, and then minus is square root of 15. Next one, this time I'm going to use the FOIL method. So the first terms is square root of 3 times square root of 4 is square root of 12. And then outer terms, positive square root of 3 times negative square root of 6 is negative square root of 18. Then the inner terms, negative square root of 2 times positive square root of 4 is negative square root of 8. And last one, the last terms, negative square root of 2 times negative square root of 6 is positive square root of 12. 12 is 4 times 3. 18 is 9 times 2. 8 is 4 times 2. And 12 again is 4 times 3. The square root of 4 is 2, so I'll factor out 2. So 2 is square root of 3. The square root of 9 is 3, so this will be minus 3 is square root of 2. The square root of 4 is 2, so this will be minus 2 is square root of 2. The square root of 4 again is 2, so plus 2 is square root of 3. And then 2 is square root of 3 plus 2 is square root of 3 is 4 is square root of 3. Negative 3 is square root of 2 minus 2 is square root of 2. Negative 3 minus 2 is negative 5. And then copy is square root of 2. Another one, so we have 4 times 4 is equal to 16. And then negative square root of 3 times square root of 3 is negative square root of 9. And then negative square root of 3 times 4 is negative 4 is square root of 3. And then positive 4 times positive square root of 3 is positive 4 is square root of 3. Negative 4 square root of 3, positive 4 square root of 3 will be cancelled out. Square root of 9 is 3, so this will be 16 minus 3. And this is equal to 13. Another one, so we have square root of b times square root of b is b. And then d times negative d is negative d squared. And then d times square root of b is positive d square root of b. And then square root of b times negative d is negative d square root of b. Positive d square root of b and negative d square root of b will be cancelled out. So this will be our final answer. Do you now see why I call it SMILE method? Now, what do you notice in our final answer? There are no more radicals. Look at our second binomial. Compare this with our first binomial. This one with this one. What do you notice? It is the same as the first binomial, only with a different sign of the second term. So this is negative and this is positive. This is positive and this is negative. We call this conjugate. It is formed by negating the sign of the second term. So the only difference of the two binomials is the sign in the middle. We will be having more of conjugate in our next video, dividing radicals. Multiplication of radicals are classified into three. The first one is multiplying radicals of the same order. In here, we are going to use the property of radical nth root of AB is equal to nth root of A times nth root of B. Let's have examples. Number 1 is square root of 6 times square root of 6. Since the indices are the same, we can combine them into one radical symbol. Let us just multiply the radicands. So 6 times 6 is 36. So this is a square root of 36. And square root of 36 is 6. Number 2, square root of 20 times square root of 5 is square root of 100. And square root of 100 is equal to 10. Number 3, 3 times 5 is 15. 1 plus 1 is 2. So this is equal to square root of 15 x squared. Since the index is 2 and the exponent here is 2, 2 divided by 2 is 1. So we can factor out 1x. So this is x is square root of 15. Number 4, let's combine them, is square root of 24. And 24 is 4 times 6. The square root of 4 is 2, so let's factor it out. So this is 2 is square root of 6. Number 5, 2 times 8 is 16. 2 plus 1 is 3. So this is equal to cube root of 16 c cubed. The index is 3. The exponent here is 3. 3 divided by 3 is 1. We can factor out 1c. And then 16 is 8 times 2. The cube root of 8 is 2. So let's factor it out. This will be 2c. And then copy what is left, cube root of 2. Let us continue. Number 6, 10 times 5 is 50. So this is a square root of 50. And then 1 plus 1 is 2. So we have x squared. Since the index is 2 and the exponent is 2, 2 divided by 2 is 1. I could factor out 1x. And then I'll express 50 as 25 times 2. Square root of 25 is 5. I'll factor it out. So final answer is 5x is square root of 2. Number 7, 5 times 25 is 125. 2 plus 1 is 3, so we have p cubed. 3 plus 7 is 10, so we have q to the 10. Cube root of 125 is 5. 3 divided by 3 is 1. So I could factor out 1p. And then how many 3's are there in 10? There are 3. So I can factor out 3 q's. So I have q cubed. 3 times 3 is 9. And 10 minus 9 is 1. So there is one more q left inside the radical symbol. Next one, 40 times 2 is 80. 1b plus 2b is 3b's. So I have b cubed. I don't have c here, but I have it here. So I'll copy c to the 6. And then 3 plus 4 is 7. So d raised to 7. The index here is 2. The exponent of b is 3. So I could factor out 1b. For letter c, 6 divided by 2 is 3. I could factor out c cubed. For d, there are how many 2's are there in 7? There are 3. So I can factor out d cubed. Now 80 is 16 times 5. 1 times 2 is 2. And 3 minus 2 is 1. So there is one more b. 3 times 2 is 6. And 7 minus 6 is 1. So there is also one more d. The square root of 16 is 4. So I can factor it out. Final answer, 4bc cubed d cubed is square root of 5bd. This time, we are going to multiply radicals with different indices but same radicands. In here, we are going to transform the radicals to powers with fractional exponent. So let's have number 1, cube root of 3 times is square root of 3. So we have the same radicands but different indices. So let's convert this into exponential form. Cube root of 3 is 3 raised to 1/3. Square root of 3 is 3 raised to 1/2. Loss in exponents, when you have the same base, you copy the base and then you add the exponents. Since the denominators are not the same, we have to determine the LCD. And the LCD of 3 and 2 is 6. So 6 divided by 3 is 2 times 1 is 2. And then we copy plus. 6 divided by 2 is 3 times 1 is 3. 2 plus 3 is 5. So we have 3 raised to 5 over 6. And then we're going to convert this into radical form. The denominator will become the index. So this is 6 root of 3 to the 5th power. And 3 raised to 5 is 243. So 6th root of 243. Next one, this is 3x squared raised to 1/2. And then 3x squared raised to 1/3. So we have the same bases, 3x squared, copy the base, and then add the exponents. So 1/2 plus 1/3 is just the same as 1/3 plus 1/2. So this is also equal to 5 over 6. So we have quantity 3x squared raised to 5 over 6. And then we distribute the exponent. So we have 3 raised to 5 over 6, and then x squared raised to 5 over 6, that will be 2 times 5 is 10, so x raised to 10 over 6. And then let's convert this into radical form. 6 will become the index. So 6th root of 3 to the 5th, x to the 10th power. Since there is 1 6 in 10, I can factor out 1x. 3 to the 5th again is 243. 1 times 6 is 6. And 10 minus 6 is 4. So there are 4 more x's. X to the 4th. This time, let's have the most challenging one. Multiplying radicals with different indices and different radicands. In here, we are going to convert the radical into powers having similar fractions for exponents and rewrite the product as a single radical. Number 1, so I'm going to express this into exponential form. I'll express 4 as 2 squared. So this will be 2 squared raised to 1/4. And then this one is 2 raised to 1/3. Then I'll multiply the exponents. 2 times 1 is 2. So I have 2 raised to 2 over 4. And then I'll copy 2 raised to 1/3. Loss in exponents, same base. I'll copy the base. And then I'll add the exponents. Since the denominators of my exponents are not the same, I'll determine the LCD. And the LCD of 4 and 3 is 12. So 12 divided by 4 is 3. Times 2 is 6. And then this is plus. 12 divided by 3 is 4. Times 1 is 4. And then 6 plus 4 is 10. So this is 2 raised to 10 over 12. Both are divisible by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. So this is 2 raised to 5 over 6. Then I'll convert this into radical form. 6 will become the index. So this is 6th root of 2 to the 5th power. And 2 to the 5th power is 32. So final answer is 6th root of 32. Another one, this is 2 raised to 1/5 times 3 raised to 1/3. Now this is different because my bases are not the same. Unlike here, the bases are the same. I can copy the base and then add the exponents. In here, I cannot do that. So the objective is to have fractional exponents that are similar fractions, meaning the denominators are the same, because that denominator will become my index later. So I have to think of a number that I will multiply with 1 over 5 and 1 over 3 that will give me the same denominator. So I'll multiply 1 over 5 here by 3 over 3. 3 divided by 3 is just 1, so as if I did not multiply anything. And then I'll multiply 1/3 with 5 over 5. Again, 5 over 5 is just 1, so as if I did not multiply anything. Now, 1 times 3 is 3, 5 times 3 is 15, so I have 2 raised to 3 over 15. Here, 1 times 5 is 5, and 3 times 5 is 15. So I have 3 raised to 5 over 15. Now I have the same denominators. This will now be my index. So this is 15th root of 2 cubed 3 to the 5th power. And 2 cubed is equal to 8. 3 to the 5th is 243. So 8 times 243 is 1,944. Let us have one more. This is a binomial times a binomial. I'll make use of FOIL method here. So square root of 2 times square root of 2 is 2. And then square root of 2 times negative fourth root of 4 is negative square root of 2 fourth root of 4. And then cube root of 4 times square root of 2 is positive square root of 2 cube root of 4. Positive cube root of 4 times negative fourth root of 4 is negative cube root of 4 times fourth root of 4. And then I'll copy this one. I'll convert this into exponential form. Square root of 2 is 2 raised to 1/2. Fourth root of 4 is 4 raised to 1/4. Again, square root of 2 is 2 raised to 1/2. Cube root of 4 is 4 raised to 1/3. Again, cube root of 4 is 4 raised to 1/3. And fourth root of 4 is 4 raised to 1/4. Then I'll copy this. And then I'll express 4 as 2 squared. So this will become 2. And then the exponent 2 times 1 is 2 over 4. So 2 raised to 2 over 4. And then I'll copy this 1 as well as this. And just like this one, I'll express 4 raised to 1/4 as 2 raised to 2/4. I'll copy this again. Lowest term of 2/4 is 1/2, so 2 raised to 1/2. I'll copy this as well as this one. Again, lowest term of 2/4 is 1/2, so 2 raised to 1/2. Positive 2 raised to 1/2, 4 raised to 1/3. 4 raised to 1/3, 2 raised to 1/2, negative. So this 2 will cancel out. And then I'll copy this. Loss and exponents, same base, we copy the base, and then we add the exponents. Since the denominators are the same, we simply add the numerator and copy the denominator. So 1 plus 1 is 2, so this will be 2 raised to 2 over 2. And 2 raised to 2 is 1, so this will be 2 minus 2. Final answer is 0. Quick tips. When multiplying radicals with the same indices, simply multiply the radicands. When multiplying radicals with different indices but same radicands, convert the radicals to exponential form and apply the loss on exponents. When multiplying radicals with different indices and different radicands, convert the radicals to exponential form with exponents that are similar fractions. And finally, always express the final answer in simplest form. Now it is time to check your understanding. Pause this video for more time. Let us answer. Number 1, square root of 5 times square root of 4 is square root of 20. And then square root of 5 times 7 is 7 is square root of 5. 20 is 4 times 5. And then I'll copy 7 is square root of 5. Square root of 4 is 2. I'll factor it out. So this is 2 is square root of 5. And then I'll copy this again. Similar radicals, 2 plus 7 is 9. So 9 is square root of 5. Number 2, remember this, the conjugate. The only difference is the sign at the middle. I'll teach you a technique here. All you have to do is to square the first term. So square root of 6 squared is 6. And then this is always minus. And then you square the second term. Square root of 5 squared is 5. 6 minus 5 is equal to 1. That's it. Let's have number 3. This is c raised to 5 over 3. And this is c raised to 3 over 4. Lowes on exponents, same base. We copy the base and then we add the exponents. Since the denominators are not the same, we have to determine the LCD. The LCD of 3 and 4 is 12. 12 divided by 3 is 4 times 5 is 20. Of course, this is plus. 12 divided by 4 is 3 times 3 is 9. 20 plus 9 is 29, so this is c raised to 29 over 12. Then I'll convert this into radical form. This will be my index. So 12th root of c raised to 29. Then how many 12 can you form in 29? There are 2. So we can factor out 2 c's. So let's have c squared. And then 2 times 12 is 24. 29 minus 24 is 5. So there is still 5 c's inside the radical symbol. Gets?